Okay, welcome to this lesson. So we will revisit the model analysis process we previously performed using PyTorch. So our primary goal is to identify misclassifications in our trained model on the MNIST dataset or the MNIST handwritten digit dataset. We need to generate a completion matrix and produce a classification report. To get started, open the corresponding Jupyter notebook to the Google column. So we already attach it in our Google Classroom, the link of this Google Drive. So I've already done so. And now let's walk through the lesson step by step. So now let's import necessary PyTorch functions. Once imported, we confirm that we are utilizing the GPU for computation, which enhances the performance. So now we have here the image plotting function here for our reference for um, plotting those images for predicting the each images, no, in this case. So we need to use this plotting function here, and what we have here is okay, loading our loading and preparing our test data here. So now let's load our test data set similar to our previous workflow. So we need to define the necessary data transformations, including converting images to tensors, and also normalize them, no? And also we need to load the MNIST dataset using the Torch Vision datasets that MNIST. And we need to create a data loader to efficiently efficiently batch and processes images. Okay, so and what we have here is, so in PyTorch, we must explicitly define the model architecture before loading it. So this means we need to setting up a class to outline the model structure prior to um, prior to restoring its trained weights. Okay, so next we need to load our model. So I already uploaded the model to my Google Drive here. So you need to use the gdown function. Then you need to download the trained, or we say the trained model, no, that we already um we already trained it to, I think it's in 10 epochs. Okay. So next is here this area here is restoring the trained model. So we need to reload it using, yeah, where is it? Okay, torch load. So now we reload it using torch load. So this is the this is the file that we already I already trained the MNIST dataset for 10 epochs, no? This PTH file here. And well, this is the stored state dictionary, no, of our trained MNIST CNN. So with the model successfully loaded here, so we are ready to perform inference. So running inference. So we need to add this one. No? To run inference, so we need to disable PyTorch AutoGrad. So using the torch no grad, which reduces the memory usage and speeds up computations. So we need to iterate over our test data into batches. So pass the images to through the model to obtain predictions. And next is to compute the total number of correct classifications. So after executing this, we achieve or the model achieve 98.7% accuracy. So well, it is a great improvement. No? So although our model performs well, so it is crucial to analyze its misclassification. So this one in this cell, this helps us understand which digit classes are most often confused, and well, and let's check why by inspecting misclassified image here. So we need to identify challenging cases where even humans might struggle. So as you can see, we have this image here. So the actual label is 3 and the predicted label is 8. Obviously here, for me, if I want to check this image, so it looks like 8, though well the actual label here is 3. And well, for this example, so actual label is 4, the predicted label is 9. So well, as you can see, it looks like almost 9. And this one, very difficult one. So the actual label is 4, the predicted label is 2. And for me, it looks like an H. And here is actual label 6 and the predicted label is 0. So I think the model understand this one would be a noise, no? And so on. Okay. So well, let me check. Okay. So right now, we need to generate confusion matrix and classification report. So in this cell here, so we have generated a confusion matrix. So right now, as you can see, so as you can see in this image, so the columns here is the predicted classes. This one, no, as you can see, and let me use this one. Okay, so this one is the and on the top of this or the column name should be the uh, predicted outputs or the or each classes. Then this one in here on the right side is the ground truth labels. So as you can see here, we have um, a lot of there's some points here have a misclassification. For example, uh, sample here, no, in class 9. So actual labels is 9 and it predicts, you know, it predicts 8 three times here. So we have 3 misclassifications as 8 instead of 9. So here in this diagonal line here is the most of the predictions are correct. So like sample, this 973 here um is the correct classifications of zeros. And this one, ones, two, three, four, five, six, seven, eight, and 10. Okay. Next is, so we need to check the classification report using the scikit-learn, no, confusion matrix. And we need to check this one. Okay, so this is the confusion matrix of our model. So we have an overall accuracy of 98.7%, and we have a misclassification of 0.1 to 12, um 0.0127 here. As you can see, we have an accuracy per class. So in my end, so I think if you want to rerun all this Google Colab, well, we will have a different result. For in my case, we have the highest accuracy here is I think accuracy 1 for class 1. So we have 99.383%. And the lowest here is class 9, no? I think, okay, class 9. We have 97.721%. So in second learn, we use we just import the classification report. And what we have here is the precision recall F1 score support. So for recall, so it is the actual true positives over how many times the classifier predicted the classes. So what we have here is we have uh, we have per class. So we have a good recall here. Also, we have precision. So number of correct predictions over how many occurrences of that class were in the test datasets. Okay, so we have, for example, in precision. So well, it still has good precision values here, no, as you can see. Okay, so well, this is how to um, check, no, the um, accuracy of your model, no. So we need to generate a confusion matrix to analyze prediction patterns, and we need to create classification report for a deeper performance breakdown. Well, just rerun this Google Colab, observe and check, no, if well, of course, so in our test loader here, so we have a different batch of test data set at yes, no, that batch test data set for I think it is 128, no, batches per batch, no. So just check, no, if there is changes regarding to the accuracy here, and try to check the confusion matrix. And well, thank you for following along. So let's proceed to the next step in our analysis. So thank you for listening.